All right, so for example, when we're talking about a log function, if you're looking at the natural log, if you want to find the derivative of the natural log of x, it's simply going to be 1 over x. So anytime you're trying to differentiate, if you see a function where you need to take the derivative of natural log of x, it's simply going to be 1 over x. Any other logarithmic function with a different base. So remember, a natural log has a base of e. So if you're trying to find the derivative of a log function with any other base besides e, there's your 1 over x. But it's going to be 1 over x times the natural log of the base. Again, you can apply the same rule for natural log of x. Again, we differentiate the natural log of x. Again, looking at this particular rule, it's equal to 1 over x times the natural log of e. But what is the natural log of e? The natural log of e is just what? 1. So that's why when you take the derivative of the natural log of x, the rule is slightly different. But any other base, again, is going to be 1 over x times the natural log of v. All right, so any questions on that? You need to remember all those properties of logarithms when you're using the derivatives. So you will want to apply some of these derivatives. So for example, if you take a look at the natural log of square root of x plus the quantity of natural log of x to the square root. Oh, we got. So notice the difference in this particular notation. Again, we've got, if I look at this particular, anytime you're doing derivatives, I'm going to change these radicals into fractional exponents. So I have the natural log of x to the 1/2 plus the quantity of natural log of x raised to the 1/2 power. So be careful with the difference of those notations there. All right, so now the question is, what rule am I going to have to apply to differentiate natural log of x to the 1/2? I'm going to have to apply my what? Chain rule. This is a chain rule. So the derivative of the outer function. So again, to find my y prime, again, the outer function is the natural log function. So anytime you differentiate the natural log function, it's going to be 1 over whatever's inside the log. So 1 over x to the 1/2 times. Now you have to differentiate x to the 1/2. So again, what is the derivative of x to the 1/2? That's going to be what? 1/2 x to the negative 1/2, or 1 over 2 times the square root of x, or x to the 1/2. Any questions? So that's just taking care of the natural log of x to the 1/2. Plus, now you have the quantity of natural log of x to the 1/2 power. Now remember, what you can do is you can apply your properties of exponents. So again, when you go to take the derivative of the outer function, the derivative of the outer function is what's raised to the 1/2 power. So again, I'm going to use my power rule. So it's going to be 1/2 times the natural log of x raised to the negative 1/2 times. What is the derivative of the natural log of x? The derivative of natural log of x is what? 1 over x. Okay? So now when I clean this up a little bit, let me go ahead and let me multiply the 1 over x to the 1/2 plus 1 over 2x to the 1/2. So when I multiply these two fractions together, my numerator is going to be a 1 over, what is x to the 1/2 times 2x to the 1/2 going to give me in the denominator? That's going to give me a what? 2x. Plus, get rid of the negative exponent, so that's going to be plus 1 over 2x times the natural log of x to the 1/2. So there's your derivative. Like I said, you've got to be on the lookout from this day forward for chain rule. More often than not, you're going to have to apply your chain rule versus not. Yes, Brielle? Okay. So any questions on A? So let's take a look at B. Y equals the sine squared of the natural log of x. Now, first of all, identify the operation. Are you multiplying sine times the natural log of x, or is this a composition? Are we multiplying sine squared times natural log, or is this a composition? Identify this first. It's a composition, so I'm not using product rule. Remember, anytime you're dealing with a trig function raised to the second power, rewrite it with the parentheses. Remember what this is equivalent to. It's equivalent to the quantity of sine of natural log of x, all raised to the second power. So now you can see we're going to be dealing with the chain rule. Again, start on the outside, work your way in. What's on the outside? You've got something raised to the second power, so we're going to apply the power rule. So I have 2 times this quantity of sine of natural log of x raised to the first power, times. Now I've got to look at my inner function. My inner function is the sine of the natural log of x. Do I have to apply my chain rule again? Yes, because the outer function is sine. So what's the derivative of my sine function? The derivative of my sine function is what? Cosine. So I have times the cosine of the natural log of x times. So I've differentiated the outer function, the square. I've differentiated the sine. Now I'm going all the way to the inside. What's the derivative of natural log of x? 1 over x. So there's your derivative.
We just put x as a denominator here?
Yeah. Mm-hmm. Any questions on B? Okay. So any questions on how you differentiate the natural log of x? So now let's take a look at the log functions where the base is no longer a base of e. So again, remember, the rule when you're differentiating your log function with a base other than e, it's going to be 1 over x times the natural log of whatever the base is. So my base is 2. So again, ask yourself, do you have to use your chain rule here? Do you have an inner function whose derivative is not equal to 1? Yes, so you are going to have to apply your chain rule. The outer function is your log base 2. So then y prime is simply going to be equal to 1 over x squared plus 5x times the derivative of the inner function. And what is the derivative of x squared plus 5x? So be 2x plus 5. Now don't forget, what do you also have to include in this denominator? 1 over x squared plus 5x, but it's going to be the natural log of the base, natural log of 2. So my final answer is going to be 2x plus 5 over x squared plus 5x times the natural log of that base, which is 2. Okay. Any questions on that one? Yes?
How would you get the 2x plus 5?
You have to use your chain rule. So again, your outer function is just the derivative of log base 2, which is 1 over x squared plus 5x natural log of 2. But now you've got to look on the inside. You've got to look at the derivative of the inner function, which is the x squared plus 5x. By your chain rule, you have to multiply by the derivative of x squared plus 5x, which is 2x plus 5. Okay. Questions on C? Let's look at D. You have log of the cosine squared of x. Are you multiplying log and cosine squared together, or is this a composition? Composition. So the first thing we need to do, what is the base, by the way, of this logarithm? It's a base of what? 10. So the first thing I'm going to do, again, I'm not going to worry about what's on the inside yet. Let me worry about differentiating the outside function, which is log base 10. So then my y prime is going to be equal to 1 over cosine squared of x times natural log of 10. So all that's done is taking the derivative of the outer function, which is 1 over cosine squared x times the natural log of 10. Times. Now I need to worry about differentiating the inner function, which is cosine squared x. Remember what this cosine squared x notation means. It means the quantity of cosine of x to the second power. Do I have to use my chain rule again to differentiate cosine of x to the second power? Yes. So again, the derivative of the outer function is going to give me 2 times the cosine of x times. Now I've got to look at the derivative of the cosine of x. The derivative of cosine of x is a what? Negative sine x. Can you simplify this fraction right now? Remember, this is all over 1. What can you cross cancel? You can cross cancel a what? Cosine of x. So my final simplified answer will be negative 2 sine of x over cosine of x times the natural log of 10. There's another way you could even express your answer. Anybody want to take a wild guess? Because if you're doing multiple choice, they may express it. What is sine over cosine equivalent to? Tangent of x. So you may also see this. Negative 2 tangent of x over natural log of 10. So all those are equivalent. like I said, when you're dealing with multiple choice, you've got to make sure you can recognize your answers expressed in different ways. Again, if it's a free response question, I would have accepted this. All right, but again, just so you know, you got to make sure you can get those answers. Just like when you're checking your homework, make sure you can understand where those answers are coming from. All right, any questions on that? Again, just a review, you've got some properties of logarithms which we may have to use when it comes to differentiating log functions. Remember your product property of logs. If you're taking the log of a product, you can split it apart into the natural log of x plus natural log of y. Because as you know, ladies and gentlemen, taking the log of sums and taking the derivatives of sums and differences is much easier than having to use a quotient or a product rule. So again, you wouldn't want to use your chain rule. If you saw a natural log of x and y, you wouldn't want to have to apply your chain rule here. Because this would be a chain rule problem, then you'd end up using the product rule. So you could take this product and split it up, which would make finding the derivative much easier. Same thing if you have a quotient. So if you're taking the log of a quotient, instead of having to use your chain rule and then use your quotient rule, it'd be much easier to use your property of logarithm and split this up into a difference. Just like if you have a log raised to a power, you can use your power property. So for example, find the derivative for natural log of the quantity of x minus 1 over x plus 1 raised to the 4th power. Again, this is where you'd want to use your properties of logarithms first. You wouldn't want to have to worry about using your chain rule here. So again, the first thing I can do, what can I do with this power? I can move this power to the what? Front. So I can rewrite this as y is equal to 4 times the natural log of x minus 1 over x plus 1. Now, how can I split apart this logarithm? I can use my quotient rule for logarithms. So I have 4 times the natural log of x minus 1 minus 4 times the natural log of x plus 1. So I haven't done any calculus yet. All I've done is I've used my properties of logarithms. Yes, Kate?
Would it be to the third?
No, because I'm not doing anything with derivatives yet.
Okay.
I'm not doing, all I've done is I've used my properties of logarithms. The idea is by using your properties of logarithms, when you go to find the derivative, it should be much easier. Now, you could keep the 4 factored out if you want. In other words, you can keep the 4 out the very front if you want and have all that in parentheses. So any questions? So I've just expanded using properties of logarithms. I haven't done anything with derivatives yet. Any questions about the properties of logs? Now let me worry about finding my derivative. So my y prime. I have my constant 4. So now let me worry about differentiating natural log of x minus 1. Well, what's the derivative of natural log of x minus 1 going to be? That's going to be 1 over x minus 1. Notice I don't have to use my chain rule because the derivative of x minus 1 is a 1. Minus 4. What is the derivative of natural log of x plus 1? That's just going to give me what? 1 over x plus 1. So this derivative is going to be 4 over x minus 1 minus 4 over x plus 1. Okay. So again, much easier if you can use your expansion, write it as a sum and difference if you can, because it's easier to differentiate term by term than it's easier to differentiate a product or a quotient. So any questions on that one? All right, so let's take a look at one application of derivatives that may help us when finding the derivative more complex.